This is fine. All right. So really great to be here in person, actually. Truly fantastic. This talk is titled A Developer Experience for the Cloud Age. And I'm André. I'm the founder of a startup called Encore. And our mission is to help the world build better software faster. Before that, I was at Spotify for many years as a backend engineer. And this is, in many ways, it's a talk about the lessons learned there. So what does a developer experience for the cloud age mean? Let's find out. So this is the daily usage graph of Microsoft Teams from 2019 to April 2020. And this is the graph for Zoom. And this, in many ways, it represents the massive growth that happened in just a matter of a few weeks, where hundreds of millions of people started working from home when the pandemic hit. And I think if you look back 20 years ago, nobody really expected the internet to be as big as it has become. And in many ways, I think the pandemic has given us an even higher degree of respect and understanding for truly how critical it is to our modern lives. And when it comes to building software for the internet, these days we're no longer building with a single server and just deploying some code there. Maybe we have a database on the side. Whether it is for massive scale or availability and reliability, increasingly about regulations as well, or just about a good user experience, we don't build software by just deploying it to a single server. What we do instead is we build distributed systems. And how do we build distributed systems? We use the cloud. Now, what is the cloud really? If you ask Merriam-Webster, you get this sort of thing, which is maybe not the most useful. This is what most people think about, right? And I started thinking about this, what about AWS was really different from what came before? And there were these VPS providers where you could just click a button and get a virtual machine running in a data center somewhere. So it wasn't really about the servers. What was different about AWS was that they started thinking about infrastructure as services. And they launched with these 3 services: EC2 for virtual machines, S3, which is what we today call object storage, for storing files and unstructured data, and SQS, which is the simple queue service, which provides a really simple API for doing something really complicated, which is how do you build massively scalable, reliable, distributed asynchronous message passing for decoupling systems from one another at scale. And if you work with backend development for some time, you start to notice that you start to use these patterns and concepts again and again. And it's really more like, instead of thinking about them as services, we've started to think about them as building blocks of how we build software. And so you have your APIs and your services that's where you write the code. But then there's all these other services that you use to construct your software. Everything from queues and object storage to caches and databases and so on. And so if you think back 15, 16 years ago, the vast majority of the behavior of your application was really about the code that you were writing. But today, that's actually a minority of the behavior, and the majority of the behavior comes from composing different cloud services together to construct your application out of these building blocks. And this is a pretty radical change in just over 15 years. And so my conclusion is how we develop backends has fundamentally changed in the last 15 years. And we don't really think about this. We still think like, we're backend developers, we're writing code, that's our job. But is that really true? And there's this cloud native movement, which many people think is about Kubernetes and containers and DevOps and observability. And if you do that, then you're cloud native. But I think a more useful definition is actually that you're cloud native if you're thinking about your software in terms of these primitives and constructing that software with those primitives. So in many ways, cloud software is no longer written, it's actually composed. And so when we talk about the clouds, oftentimes it's these fluffy, suspended particles in the air that Merriam-Webster talks about. But in many ways, it's also, they can have a darker side. And there are three big problems with, how we build software these days. And maybe the biggest one is boilerplate. Maybe not the biggest one. And I was thinking, how should we visualize this? And, well, the answer was easy, Kubernetes, right? This is the YAML for a microservice backend with just 5 small services, courtesy of the Q project from one of their tutorials. And this is the actual YAML just printed. And actually, this is just half of it. Here's the other half. This is the actual, it's 38 pages long. Oh, this is maybe hard to see. So when you're building a distributed system and you have all of these services, what happens is every single service that you build, you do the same work over and over. You're setting up all the boilerplate around the service, you're setting up an infrastructure, you're configuring everything, you're doing your monitoring and observability stuff, DevOps. And then within the code base itself, every single thing you do where you're interfacing with something else, it's even more work. You're making API calls and doing HTTP requests and all of this stuff. So everywhere you look, there's this constant overhead in terms of boilerplate and toil. The other big problem is complexity. When we're starting to build software out of these components, the number of components has grown incredibly. And this is the official recommendation from AWS on how to set up WordPress. Moving on. And really, as we've moved away from just writing code, the behavior of our application is broken up into all of these different places. You have your code, but you also have your infrastructure, you have your configuration and Terraform and this sort of thing. And it's very hard to get an understanding and an overview of what our system actually does. And we talk about observability, but really these tools are really just scratching the surface of what it would mean to actually understand, and help us understand the software that we're building. And even when you do that, they're always out of sync with each other. So you're never really quite sure, is this change going to work when I deploy it? And maybe the third part is, the sum of these two, and it's, creating this really frustrating and awful developer experience. And I think of it as a Rube Goldberg machine where you're building your development process by integrating all these different tools together. And individually, they're all great, and they do their job really well, but they have no idea what the rest of the workflow looks like. So, you're just taking them and combining them together and just creating this monster of a development process, right? And you have to do all this work and just orchestrate them just right for everything to work out. And hopefully, if you're lucky on a Sunday, what comes out the other end is actually working software. So as I said, how we develop backends has changed, fundamentally. But our tools haven't really. We're still using the same tools, and still just writing code in terms of like opening a file and starting to write code. So what would a better developer experience really look like? And I won't pretend I have the answers, but I certainly have been thinking about this for a long time. And I'm going to show a couple examples of how we're approaching this problem with Encore. It's all open source, so if it sounds interesting, please check it out. But more than that, I would love to hear your thoughts, because this is a hard problem. We don't really know what we should do in terms of solving these problems, but what's very clear is, the way we're doing it today isn't really cutting it. So yeah, come find me if you have ideas. I would love to hear them. And so if the two big problems are around, reducing boilerplate and getting a grip and handle on all of this complexity that's inherent in how we build with the cloud, perhaps the first thing we need to do is we need developer tools that actually understand what it is we're doing. Because when our tools don't understand what we're doing, how could they possibly help us? So I'm going to do a quick live demo, hopefully, fingers crossed, to show you what I mean. I'm going to mirror my display. Wonderful. So let's say that we want to create a very simple application. And I was going to do like a to-do list thing, because that's what everybody does. But I realized we need to go bigger. So I call this an issue management system. And so what's an issue? Well, it has a title, and it's either done or not, right? So that's this. And the only thing our issue management system will do is it will let you create issues. Because let's be honest, we're not actually solving anything. So let's model the real world, shall we? And so what do you need to do that, right? Conceptually, you need an API. And that API should receive a title, and it should return the issue that was created. And then we need a database to store that. So this is a very simple file that has these components, right? Here's a function which takes as input a title and returns the created issue. And then we have a database, a reference to a database. And in this API is just conceptually, it's just a function, right? That's what APIs are. And this API then, inserts a row into the database, gets back the ID that was generated, constructs the issue, and returns it. And we can be explicit that issues are never actually done. But why is it that we need to do anything more than this? This should be enough. But when we build software, there's like hundreds of other things that we need to do. So when we're running things locally, we should just be able to say, run something, and then it runs. And we should be able to, this is a bit small. Let me make it big. So we should be able to just, post an issue and say, well, the Kubernetes YAML is just too long, and it should just work, right? Like, we just created an issue here. It generated an ID and everything, and we can go into the database and take a look. And there it is. And so how does Encore do this? Well, it's all based on understanding the software. So what we have here on the right is actually Encore's view of the system that we just built over here. It understands that there is an issue service. It has I can zoom in a bit, maybe. We have a service over here that is connected to a database, and that's our API. So this is all done by analyzing the code and understanding, what are the different parts of the system, and then doing a lot of code generation to generate all of the boilerplates that we traditionally need to use. And so this is one way of solving this problem of immense amount of boilerplate. We're really getting down to the conceptual level of what an API is all about. So we could take it a step further. When you're building these distributed systems, you have multiple services. And we're not really building, a to-do list here. We're building an issue management system. So we're going to need notifications and integrations. We're going to need a Slack integration. That's what people do. Let's create a Slack service, and we're going to say, notify created issue. Now let's make this an API. So when you create this API, Encore immediately updates its understanding and says, oh, there's a Slack service over here. It's not connected to anything. So let's change that. So when we create an issue, let's ping the Slack service, and we can just ignore the error here. And then we immediately see, oh, the issue service is talking to the Slack service. Look at that. And this is great and all. And we can just run this and set it all up. And that's wonderful. But there's just one problem with this, if this is just a developer tool, we've just done the easy part, which is, running something locally. Anybody can set up a Docker container. And that brings us to the second big challenge that we have, which is integration. It's not enough to just have a tool that understands, because the problems are so much to do with how we're building with the cloud. And how can our tools help us if they're just, one cog in this Rube Goldberg machine? We really need tools that are integrated into our workflow and integrated with our cloud provider. So if we go back here, in many respects, what's different about how we're approaching this with Encore is that, it's not just an experience for your local machine. It's actually a connected experience that integrates all the way out into production. So to actually set this up in the cloud, all you have to do is git push, and we'll figure out the rest, and it will trigger a build and deploy it and so on. And this is an actual live demo, so who knows if it will work. We'll wait on it a few seconds. But when you're building systems, it's not, and we can see if this actually completes. But when you're building systems, databases and APIs only gets you so far. We need all of these primitives that we talked about. We need object storage, and we need queues and pub/sub and caches and CDNs and so on. And so our vision is really, going from writing code to natively being able to express these concepts directly in our code, and not having to juggle, Terraform and our cloud provider and our code base, and not really understanding anything. Okay, so now it's actually deploying. Okay, so now it's up and running. We get our API over here. We can call it. And there's a fully running backend up and running in the cloud. And we didn't really have to do anything beyond express conceptually what we want. But like I said, it's not enough to just do this in terms of APIs and databases. We need more. So let's say that this is an enterprise issue management system. We don't want direct connections between services. We want to decouple this. It's enterprise. So let's create a queue, and the queue is going to contain events. So let's create the issue event. And that will have the issue itself, and it will have the event type. And now I'm actually using generics here. So beware. So conceptually, this is just what a queue is. It has a name, which is needed when you're interfacing with the cloud, like resources need to have a unique name. And this is the data type that's actually being pushed over the queue. So instead of actually calling this API, what if we instead just publish a task on this queue, and then we don't need to care about where it's going, because this is enterprise. Like so. And then here, we can say this is a message handler for this queue, which is named issue notifications. And it's going to take a sorry. And when we do that, I was actually hoping that this would reload, but it didn't want to do that. Let me fix that. Why do you not work? Oh, it's not running, which is what we use. Okay. So now you can see that this API call has actually been replaced with a queue, which I beautifully rendered like this. And so this is way more enterprise. So now, when we receive a message, we can say issue event ID. And when we run this again locally, we can see that this actually, I'll make this bigger. We can see that this event handler was actually being called here. And so now we have a fully functioning queue. But let's make this a bit more interesting. Instead of actually, just logging to disk, logging to our console, let's actually, notify Slack, because we're crazy here. So here's just, like a small thing I prepared, which is actually calling Slack's, webhook API, and it's passing in some arbitrary text. So here, we can say send to Slack. We're going to pass in the context. And the issue and if there was an error, we're going to knack it and say, please redeliver. And if there was no error, we're going to say everything went fine. So conceptually, this is a fully functioning microservice architecture with a database and a queue, very, very enterprise. So let's push this to Encore. And we'll wait for this to complete. It's going to take a few seconds. And so what is it that we're really doing here? I think in many ways, we're trying to do the same thing the game engines have been doing, where a game engine conceptually is, changing how we build games by providing this really integrated experience that really understands what it is we're doing. And you can create some really remarkable games in a very short amount of time that is like, the productivity is off the charts compared to how we're working. More than 70% of the top 1,000 games are built with Unity on the app stores. And so what we really need is we need this concept, but for backend development. So we need like a backend development engine. And I've just really showed you, what is the way we think about it in terms of like where we are today. But conceptually, like what could we do if we had something like that? We could really come up with entirely new experiences in everything from like how we are designing software to how we're collaborating to how we're debugging and having observability into our systems. How we're writing tests and how our tools can help us understand what are the tests we should be writing and what behaviors are not tested. So here's like a PagerDuty alert. Like you wake up in the middle of the night and this is all you get. Like great, I'm gonna have to figure out what's wrong. What if instead, our tools were more helpful and they could say, the issue service is down. And the problem is that the circuit breaker to the Slack service tripped because there were too many requests being retried. And the root cause was this pull request that was being merged 7 hours ago with 98% probability. This is actionable. And you could actually do this if our tools understood what the hell is going on. Same thing with code review. You know, conceptually, the changes we do are about, you know, I'm adding this API, I'm changing this API call to a queue instead because it's more enterprise. But we're reviewing it by looking at lines of code that have changed. And we're trying to make sense of that. What if instead we could make sense of it in terms of the architecture and the changes that were being made? You know, we're adding this service. We're adding an API call. And then our reviewer could say, you know, this looks great, but what do you think about using a queue instead? Just by looking at this picture. You don't have to dig into lines of code to figure this out. So if we go back here, finally, you know, it's all up and running. We're going to call this. And I pushed this to our Slack group. So if everything worked, there should be a Slack message just now in our Slack channel. And there it is. So that's all I had. Thank you so much for listening. Would love to hear your thoughts on how we as an industry can change how we're building software, given that everything has changed in the last 15 years, and our tools really haven't. Thank you so much.